Math 1108, Section 8.4, Operations with Radical Expressions. We'll start by adding and subtracting radicals. Like radicals can be combined by adding and subtracting. Simplified radicals are called like radicals if their indexes, variable parts, and radicands are the same. Like radicals may have different numerical coefficients. We'll simplify by adding or subtracting where appropriate. In these four examples, all of the radicals are already as simplified as they can be. So we'll just go ahead and combine by adding and subtracting. 11 times the square root of 3 minus 7 times the square root of 3. This is just equal to 4 times the square root of 3. The next one, 5 times the square root of x plus 3 times the square root of x minus 1 times the square root of x. That simplifies to 7 times the square root of x. In the next one, notice on these radicals that we're adding, there's a variable y on the outside of each, but they have the same index, the same variable parts, and the same radicands. And the radicals are already as simplified as they can be. So 14y times the cubed root of 9x plus 11 times y times the cubed root of 9x. Those can be combined by adding for a total of 25y times the cubed root of 9x. And then this one, these radicals are simplified and they have the exact same indexes, the same radicands, and the same variable parts on the outside. So 13 mn times the fourth root of 7r minus 10 mn times the fourth root of 7r. That combines to give us a total of 3 mn times the fourth root of 7r. In the next few examples, the radicals are not all simplified, so we have to simplify first, and then if the resulting simplified radicals are like radicals, we can combine by adding and subtracting. The square root of 75 can be simplified. The largest factor of 75 that's a perfect square is 25. So we can write this as the square root of, 2 times the square root of 25 times the square root of 3. And then minus the largest factor of 48 that's a perfect square is 16. So we can write this as minus 9 times the square root of 16 times the square root of 3. 16 times 3 is 48. And the square root of 25 is 5, and 2 times 5 is 10. So I'll just write 10 times the square root of 3 for this one. And the square root of 16 is 4, and 9 times 4 is 36. So I will write minus 36 times the square root of 3. And then we can combine these by subtraction. 10 times the square root of 3 minus 36 times the square root of 3 is negative 26 times the square root of 3. On the next one, we'll have to simplify the square root of 45 and the square root of 48 and the square root of 20. The largest factor of 45 that's a perfect square is 9. So we can write this as 2 times the square root of 9 times the square root of 5. 9 times 5 is 45. And then plus 5 times, well, let's see, the largest factor of 48 that's a perfect square is 16. 16 times 3 is 48. So this is 5 times the square root of 16 times the square root of 3. And then the largest factor of 20 that's a perfect square is 4. So we'll write this as 3 times the square root of 4 times the square root of 5. And then we'll simplify some more. The square root of 9 is 3, and 2 times 3 is 6. So this first term is 6 times the square root of 5. The square root of 16 is 4, and 5 times 4 is 20. So this is plus 20 times the square root of 3. And then minus, well, here we have the square root of 4, which is 2. 3 times 2 is 6, so this is minus 6 times the square root of 5. The two like radicals, 6 times the square root of 5 and minus 6 times the square root of 5, those combine to give us 0, and the other radical is the only thing that remains, so the final result is 20 times the square root of 3. Okay, here's another sum and a difference, and we have to simplify the square roots first. So notice the largest factor of 18 that's a perfect square is 9. 9 times 2 is 18. Y to the second is a perfect square, so I'm going to write this as 4 times the square root of 9y to the second. And then we'll multiply that by the square root of the remaining factors. There's a factor 2 that stays behind and a factor x that stays behind. In the middle term, the largest factor of 8 that's a perfect square is 4. 4 times 2 is 8. And y squared is a perfect square. So we can write this as the square root of 4y to the second multiplied by the square root of 2x. And then minus 5y. The square root of 50, the largest factor of 50 that's a perfect square is 25. So we'll write this as minus 5y times the square root of 25 times the square root of 2x. And then we'll simplify the square roots of the perfect squares. The square root of 9y to the second is 3y, and so 4 times 3y to the second is 12. I said that wrong. The 4 times the square root of 9y to the second. The square root of 9y to the second is 3y. So 4 times 3y is 12y times the square root of 2x. And then the square root of 4y to the second is 2y. And then that's multiplied by the square root of 2x. And the square root of 25 is 5, so 5y times 5 is 25y, but we have minus 25y times the square root of 2x. And these are like radicals. The variable parts on the outside are the same, and the radicands are the same. So we can combine these. 12y times the square root of 2x plus 2y times the square root of 2x minus 25y times the square root of 2x gives us a total of negative 11y times the square root of 2x. Okay, the last one on this page, we have the cubed root of 16m plus 5 times the cubed root of 54m plus 2 times the cubed root of 40m. The largest factor of 16 that's a perfect cube is 8, so we'll write the cubed root of 8 times the cubed root of 2m, and then plus 5 times the largest factor of 54 that's a perfect cube is 27, so we'll write 5 times the cubed root of 27 multiplied by the cubed root of 2m, and then plus 2 times, let's see, the largest factor of 40 that's a perfect cube is 8. So we'll have the cubed root of 8 on the outside. And this time we have the cubed root of 5m. Okay, so the cubed root of 8 is 2. So we have 2 times the cubed root of 2m. And the cubed root of 27 is 3, and 5 times 3 is 15. So we have 15 times the cubed root of 2m. And then the cubed root of 8 is 2. 2 times 2 is 4, but we're multiplying this by the cubed root of 5m. The first two can be combined by adding. They are like radicals, but the third one cannot be combined with those. So when we combine the first two by adding, we get 17 times the cubed root of 2m, and then we add that to 4 times the cubed root of 5m. Okay, we'll start on the next page. This time we're going to talk about multiplying radicals. And remember the product property of radicals. We saw this before. Let n be a positive integer, and if the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b is equal to the nth root of a times b. So we'll multiply some of these radicals. Um, my suggestion is if we're going to multiply two radicals that have the same index, first multiply the radicands and then afterwards simplify. So if we multiply the two radicands, 12x to the third y to the second times 3x to the fifth y, we get the square root of 36x to the eighth times y to the third. And 36 is a perfect square, and x to the eighth is a perfect square, and the largest factor of y to the third that's a perfect square is y to the second. So we can write this as the square root of 36x to the eighth y to the second, and then times the square root of y, and then we'll simplify the square root of the perfect square. The square root of 36 is 6. The square root of x to the eighth is x to the fourth. The square root of y to the second is y, and then we multiply that by the square root of y. That's the simplified answer. On this one, we have a cubed root of 4x times the cubed root of 2x squared. So if we write it as a single cube root by multiplying the radicands, 4x times 2x squared, it's the cube root of 8x to the third. 8 is a perfect cube, and so is x to the third, so this can be simplified to 2x, because the cube root of 8 is 2, and the cube root of x to the third is x. Okay, for a fifth root of something multiplied by a fifth root of something else, we'll go ahead and write it as a single fifth root by multiplying the two radicands. 2x squared y times 3x to the third y to the second is 6x to the fifth y to the third, the fifth root of that. The only factor in here that's a perfect fifth power is x to the fifth. So if we compute the fifth root of x to the fifth, we get x on the outside multiplied by the fifth root of everything else, which is 6y to the third on the inside. Okay, the next one, the square root of 5x to the seventh y to the fourth times the square root of 45x to the ninth y to the third. We can write this as a single square root of 5 times 45 is 225, and x to the seventh times x to the ninth is x to the 16th, and y to the fourth times y to the third is y to the seventh. Okay, 225 is a perfect square, so the square root of 225 is 15, and the square root of x to the 16th is x to the 8th. And the square root of y to the 7th is the same as the square root of y to the 6th times the square root of y, and the square root of y to the 6th is y to the 3rd, and then we just multiply that by the square root of y. Okay, I want to get to some of these binomials. Multiply these the same way that you would just multiply binomial factors. So the square root of 7 times the square root of 2 is the square root of 14, because 7 times 2 is 14. And then we subtract 5 times the square root of 7. And then we're going to add 3 times the square root of 2. And then we're going to subtract 15. And nothing else can be simplified any further than that. On the next example, we have 4 times the square root of 3 times the square root of 3, which is 4 times the square root of 9, which is 4 times 3, or 12. And then plus 4 times the square root of 3 times the square root of 5 is the square root of 15. And then plus the square root of 5 times the square root of 3, which is also square root of 15, and then finally plus the square root of 5 times the square root of 5, which is the square root of 25, which simplifies to 5. And when we combine like terms, 12 plus 5 is 17, and plus 5 times the square root of 15. Okay, we're running out of video times. The other two, you just do those the same sort of way that we did the other ones.